On September 15, 2025, a spacecraft the size of a school bus pointed its cameras at the most beautiful object in the solar system one last time, then deliberately flew itself into the clouds of a planet 900 million miles from home. It burned up in less than 2 minutes. NASA called it the grand finale. But in the 13 years before that final plunge, the same spacecraft had already done something far stranger than dying on command. It had quietly rewritten almost everything scientists thought they knew about Saturn, and it had done it with pictures so unexpected that mission scientists initially assumed their own instruments were broken. This is the story of Cassini, and the images that turned a ringed gas giant into the most surprising address in the solar system. To understand why those pictures mattered, you have to understand what nobody expected to find. Cassini launched in 1997 with a fairly modest job description. Fly to Saturn, drop a probe called Huygens onto its largest moon, Titan, and study the rings for a few years. Titan was the real prize. It was the only moon in the solar system with a thick atmosphere, and scientists suspected that underneath its orange haze there might be something resembling early Earth. Nobody was expecting the mission's most explosive discovery to come from a moon so small that most textbooks barely mentioned it. That moon was Enceladus. 310 miles across, smaller than the distance between Los Angeles and San Francisco, Enceladus had one strange property that scientists had known about since the Voyager flybys of the early 1980s. It was the most reflective object in the entire solar system, bouncing back almost every photon of sunlight that touched it. A surface that bright should have been bitterly, uniformly cold. Instead, when Cassini's infrared instruments swept across the moon's south pole in 2005, they found something that made no sense on a supposedly dead ice ball. The South Pole was warm, not warm like a summer day, but warm compared to what physics said it should be, warm enough that something underneath the ice was clearly still active. Then came the pictures that made the theory undeniable. Cassini's camera, pointed at Enceladus with the sun behind it, caught the moon's edge lit up like a fountain. Thin plumes of icy particles were shooting hundreds of miles into space from cracks near the South Pole, later nicknamed the Tiger Stripes. It was not a metaphor. Material from inside a moon most people had never heard of was physically escaping into space and forming one of Saturn's rings. Mission scientists were so startled by what the camera had captured that engineers reworked Cassini's entire remaining flight plan, sending the spacecraft skimming through the plume itself to taste what was inside it. What they found was water vapor, ice grains, organic molecules, and salts, consistent with a liquid ocean sitting beneath miles of ice. A moon nobody had planned to study seriously turned into one of the strongest candidates for life beyond Earth in the entire solar system. And it happened because of a handful of backlit photographs nobody expected to matter. If Enceladus was the discovery nobody predicted, Titan was the discovery everybody was waiting for, and it did not disappoint. In January 2005, the European-built Huygens probe separated from Cassini and fell through Titan's thick, smoggy atmosphere for 2.5 hours before landing on solid ground nearly 900 million miles from mission control. It was, and still is, the most distant landing ever achieved on another world. The pictures it sent back showed a landscape that looked almost unsettlingly familiar. Smooth, rounded stones scattered across a dry riverbed, drainage channels carved into orange terrain, the unmistakable fingerprints of liquid that had once flowed and pooled. Except the liquid on Titan was never water. It was methane and ethane, hydrocarbons that stay liquid at temperatures near minus 290 degrees Fahrenheit. Cassini's radar later mapped entire seas of the stuff pooling in Titan's polar regions, complete with waves, shorelines, and what appeared to be seasonal changes as the moon's decades-long year shifted from one hemisphere's summer to the other's. Titan turned out to be the only other place in the solar system with a weather cycle. Clouds, rain, rivers, and lakes, just built from different chemistry than the one that shaped Earth. Scientists began describing it as a working preview of what a young Earth might have looked like before life had a chance to start. While two moons were rewriting the rulebook, the planet itself was hiding something equally strange, sitting in plain sight at its own North Pole. It was a six-sided, honeycomb-shaped storm pattern first glimpsed faintly by Voyager in the early 1980s, then lost to 29 years of Saturnian winter darkness. When sunlight finally returned to the North Pole in Cassini's later years, the spacecraft's cameras captured the hexagon in full, high-resolution detail for the first time in human history. It was enormous, wide enough to swallow two Earths side by side, and it was not drifting or breaking apart the way storm systems on Earth do within days or weeks. It had held its shape for at least 3 decades, a jet stream racing around the pole at roughly 220 miles per hour, locked into a geometric pattern that still has no fully agreed-upon explanation. Saturn, it turned out, was not a placid, decorative planet quietly holding its rings in place. It had weather more violent and more mathematically strange than anything meteorologists study on Earth, including hurricanes at both poles, roughly the width of the continental United States. By the time Cassini had been in orbit for a decade, the picture emerging from its cameras had stopped looking like the Saturn system anyone expected and started looking like something closer to a functioning laboratory. The rings themselves, once treated as a static, decorative feature, turned out to be in constant motion, clumping, rippling, forming temporary moonlets that appeared and dissolved, casting shadows that revealed vertical structures rising miles above the ring. Plane. Small moons were shepherding ring particles into place through their own gravity in real time, giving scientists a working model, visible and photographable, of the same physical process that likely built entire planets billions of years ago. Saturn's rings were not a museum piece. They were an active experiment that happened to be running 90 million miles closer than any planet-forming disk astronomers could otherwise observe. Saturn's smaller, less famous moons turned out to hide their own puzzles, and two of them became minor celebrities in their own right once Cassini's cameras got close enough to see them clearly. The first was Mimas, a modestly sized moon that had been photographed only crudely by earlier probes. When Cassini finally captured a sharp, well-lit image of Mimas's surface, the internet did the rest of the work for NASA. A massive impact crater called Herschel dominates one hemisphere, complete with a central peak rising from the crater floor, and the combination gives the moon an unmistakable resemblance to a fictional battle station from a famous space franchise. It became one of the most shared Cassini images ever released, not because of any scientific breakthrough, but because it proved that the solar system occasionally produces its own coincidences stranger than anything a screenwriter could invent. Scientists took the attention seriously enough to study why Mimas survived an impact that size without shattering, and the crater remains one of the best natural examples in the solar system of how much punishment a small, icy body can absorb and still hold together. The second puzzle belonged to Iapetus, a moon that had baffled astronomers since Giovanni Cassini himself, the astronomer the spacecraft was named after, first observed it in 1671 and noticed something odd. He could only see the moon on one side of its orbit, never the other. It took more than 3 centuries and a spacecraft carrying his name to explain why. Cassini's close flybys revealed that Iapetus has 2 dramatically different faces, one as dark as fresh asphalt and the other as bright. As fresh snow, split almost perfectly down the middle like a moon that had been dipped halfway into ink. The explanation turned out to involve a chain reaction. Dark, dusty material knocked loose from an outer moon drifts inward and coats Iapetus's leading face. That dark surface absorbs more sunlight and warms slightly. The warming causes ice on that side to sublimate and migrate toward the colder trailing hemisphere, and the redeposited ice makes the bright side even brighter. A 300-year mystery, seeded by nothing more than a smudge in a 17th century telescope, was finally resolved by high-resolution photographs of a moon most people had never heard of. Even the rings themselves kept producing images nobody had a name for beforehand. Cassini's cameras caught small, temporary clumps of ring material, informally nicknamed propellers, for the shape of the disturbance they carved into the surrounding particles, forming and dissolving as tiny. Embedded moonlets, no larger than a football stadium, tugged on the debris around them. In 2013, the spacecraft photographed something even stranger, a bright arc at the very edge of the A-ring, where a brand new moonlet appeared to be forming in real time, promptly nicknamed Peggy by the imaging team. Nothing like it had ever been documented before, a possible moon caught in the literal act of being born, and it offered scientists a live demonstration of a process most models had only ever described in theory. There is one image from this era that deserves particular attention, not because it revealed a new discovery about Saturn, but because of what it revealed about Earth. On July 19, 2013, Cassini's cameras turned away from Saturn's rings and pointed outward, capturing a wide mosaic of the entire Saturn system backlit by the sun. In that frame, nearly 1 billion miles away, was a single pale dot, Earth, visible in a photograph taken from another planet's orbit. NASA had announced the timing in advance, inviting people around the world to go outside, look toward Saturn, and know that a spacecraft was looking back. The picture was nicknamed "The Day the Earth Smiled." It contained no new scientific data about ice or oceans or hydrocarbons. What it contained was scale, a reminder, delivered through a single camera shutter click from 900 million miles away, of exactly how small the vantage point of every human discovery actually is. By the time these smaller discoveries were piling up alongside the headline-grabbing ones, a pattern had become clear to anyone following the mission closely. Cassini was not simply confirming what astronomers already suspected about Saturn. It was demonstrating, image after image, how much of the solar system had been sketched in only the roughest outline before a spacecraft finally spent over a decade in one place, watching a single system change season by season instead of glimpsing it once during a brief flyby. Voyager had given humanity a snapshot. Cassini gave it a long-running film, and long-running films catch things snapshots never can. a hexagon reappearing exactly where it was left 30 years earlier, a moon's dark half slowly explained by centuries of accumulated dust, a moonlet caught mid-formation at the edge of a ring nobody thought still had anything left to create. None of this arrived without complications, and a responsible account of Cassini has to sit with them rather than rushing past. The exact structure of Enceladus' interior ocean, whether it is a single global sea or several isolated pockets, remained a subject of active debate for years after the plume images were first captured, and only later flybys and gravity measurements strengthened the case for a global ocean. The organic molecules detected in the plume are consistent with the ingredients for life, not proof of it. Cassini had no instruments capable of directly detecting a living organism, and no image, however dramatic, changes that limitation. The hexagon's precise physical cause is still debated among atmospheric scientists, with competing models pointing to standing wave patterns in Saturn's jet stream rather than a single settled explanation. And Titan's hydrocarbon lakes, for all their Earth-like shorelines, sit in an environment so cold and chemically alien that comparing them directly to Earth's water cycle is useful shorthand, not a literal equivalence. Cassini gave humanity extraordinary images and extraordinary data. It did not, by itself, answer the question of whether anything is actually alive out there. That distinction matters, and any honest telling of this mission has to keep it in view. What makes Cassini's final act so fitting is that it grew directly out of these unresolved questions. By 2017, after 13 years orbiting Saturn, the spacecraft was running low on fuel, and mission planners faced an uncomfortable problem. An uncontrolled drifting Cassini could eventually collide with Enceladus, or Titan, the two moons it had just proven might be capable of supporting life, and contaminate them with microbes hitching a ride from Earth. Rather than risk compromising the very discoveries it had made, the mission team designed the grand finale, 22 dives between Saturn and its innermost rings, a region no spacecraft had ever entered, followed by a final controlled descent straight into the planet's atmosphere. On its way down, Cassini kept transmitting data and images for as long as its antenna could hold a signal toward Earth, sending back readings of Saturn's atmosphere that no instrument had ever measured from the inside. Then, roughly 83 minutes after the signal left the spacecraft, traveling at the speed of light across the gap between the two planets, it simply stopped arriving. 20 years after launch, 13 years after entering orbit, Cassini had transformed a planet most people associated with nothing more than a pretty set of rings into a system containing at least two credible ocean worlds. An active chemical laboratory disguised as a ring system, a moon with weather and geography eerily reminiscent of early Earth, and a storm shaped like a hexagon that has outlasted 3 decades of scientific attempts to fully explain it. None of that came from a single dramatic announcement. It came from tens of thousands of individual images taken patiently over more than a decade, each one adding a piece to a picture nobody had predicted when the spacecraft first left Cape Canaveral. The mission's real secret was never a hidden photograph locked away somewhere. It was how much an ordinary camera, pointed carefully and repeatedly at the same distant planet, could end up changing the entire search for life beyond Earth. Somewhere in Cassini's archive, among the hundreds of thousands of images it beamed back before its final dive, is the exact frame that first showed those plumes lifting off Enceladus into open space. If you had to guess, which discovery do you think mattered more in the end? The ocean hiding under the ice of a small overlooked moon, or the hexagon spinning silently at the top of the planet everyone was already staring at? Leave your answer below. And if this is the first time you have heard the full story of what Cassini actually found, you already know which one surprised you most.